Hi, this is Andrea Hendricks, and I'm going to talk to you about Section 2.7, more about problem solving. In this section, we're going to talk about using percent in problems involving rates. The mixture problems are actually not something that you need to worry about in this section. We're going to solve problems involving simple interest, and then solve problems involving denominations of money. Here's a problem that involves percentages. It says in 1998, the U.S. labor force, excluding agricultural employees, self-employed persons, and the unemployed, consisted of 116,730,000 persons. Of this total, 16,211,000 were union members. To the nearest tenth, what percent of this labor force belonged to unions? Well, the way that you're going to find the percent, you're going to write the number that belonged to unions divided by the total labor force. So for us, we're going to have to write the number that belonged to unions, which is 16,211,000, divided by the total workforce, which was 116,730,000. Now, to make our calculation a little bit nicer, we can get rid of the common thousands if you would like. So this is equivalent to looking at 16,211 divided by 116,730. So you're going to need to take your calculator out and divide these two numbers. So let me do this. You have 16,211 divided by 116,730. And that will give us 0.138876 and so on. So it said to the nearest tenth, what percent of this labor force belonged to unions? Well, so to convert this to a percentage, we're going to move the decimal point 2 places to the right. So this is equivalent to 13.8876%. Or round it to the nearest tenth, which is 1 decimal place. We're going to round up to be 13.9%. The next type of word problems that we're going to look at deal with simple interest. Simple interest earned on amount that we invest. So the interest formula is I is equal to PRT. That's principal times rate times time. Now principal is the amount you initially invest. R is the annual interest rate that you earn, and we have to convert it to a decimal. It's going to be given in terms of a percent. T is the time that we invest the money in years. So just to get practice using this formula, I think you had some problems in section 2.5 that dealt with this. We're going to do this example. How much interest would you earn if you invested $200 at 5% and $300 at 6%? And of course, these are assuming simple interest. And I also need to tell you how long. Let's say that this is for 1 year. Okay. So from the 5% interest account, my interest would be equal to the principal, which is 200, times rate, which is the decimal, 5% would be 0.05, times the length time, which in this case is 1. So we would have to calculate 200 times 0.05, and of course the 1's not going to matter, and that will be $10. And then from the other account, interest is equal to 300 times 6%, which is 0.06, times again 1 year. So we'd multiply 300 times 0.06 to get $18. So the total interest we would earn from those two accounts would be $28. Not a whole lot of money, huh? That's the concept. Okay, so we're going to look at this now dealing with variables, dealing with unknowns. It says leave Win invested some money at 3% and found at 5%. The two investments produced a total of $200 interest in 1 year. How much was invested at each rate? So notice what we're going to have to figure out here is we need to know the interest from account 1, so we'll say interest 1, plus the interest from account 2 to equal our total interest that we were given. So notice for each of these interest amounts, we're going to have to use that formula, principal times rate times time, plus principal times rate times time. Now these P's and R's and T's necessarily the same, but just to give you that concept. Now this is where the problem is a little bit different because we have some unknowns, right? We don't know how much money we invested. That's what we have to figure out. So remember how we're going to do this. We're going to have to let X represent one of those values. So we'll say that X is going to be the amount invested at 3%. Why did I choose that one? Because it told us that the second account was $4,000 less than that amount. So if I know how much I invested at 3%, I'm going to invest $1,000 less than that. Remember how we write that? That's X minus 1,000. It invested at the 5% interest. Okay. So we know our principals. Our principals are X and X minus 4,000. What are our rates? Our rates are 3% and 5%. Remember 3% is 0.03 as a decimal, and 5% is 0.05. Now we were told this was for 1 year, so the time is going to be 1 in both, so we really can ignore that because multiply by 1, you just get what you started with. So the way our equation is going to come out is principal times rate times time, so we're going to have to do X times the rate, which is 0.03, times 1, which we don't need, plus the second interest amount, principal there was X minus 4,000, amount of interest, which was 0.05, or the interest rate rather. Now what are those things equal to? They're equal to total interest that we earned. Well, it says that we produced a total of $200 in interest. So that is our equation. Now you might prefer the coefficient on the left, which I do. So that would be 0.03 times X plus 0.05 X minus 4,000 is equal to 100. Now, as you learned in section 2.3, you can remove the decimals if you want, applying 3 by 100. You don't really have to. We can just keep them in. If you keep them in, you just really need to pay carefully to those decimal points. So you get 0.03x plus, now distribute, 0.05 times x is 0. Then we have to do 0.05 times 4,000, which is minus 200. That's equal to 200. Now combine like terms, 0.03x plus, we line up the decimal points to get 0.08x minus 200, and that's equal to 200. So we would have to add 200 to both sides. So we would get x is equal to 400. Now if we divide 400 divided by 0.08, 5,000. X is 5,000. What does that represent? X is how much we invested at the 3%. So we $5,000 at 3% interest. Should we invest at 5%? Well, that was 4,000 less than what we invested. That would be 5,000 minus 4,000, $1,000 invested at 5%. You could check this out. 5% is 150. 1,000 times percent is 50. And 100 plus 50 is $200 interest. The next problem is with concept. Says an artist invests her earnings in two ways. Bond, paying 6%, and 6,000 more than 3 times as much goes into mutual funds paying 5%. Her total annual interest income is $825. How much does she invest at each rate? So we have a similar setup. We have two accounts. Some goes into a tax-free bond paying 6%. So we know our X is going to be the amount we invested at 6%. Well, how much was then invested into the account paying 5%? This is tricky because it's 6,000 more than 3 times as much. So it's 3 times the X plus 6,000 is the amount that was invested at 5%. So we know that the total interest is $825, so we have to do the similar thing. We have to do principal times rate times time for both accounts, add them up, and set it equal to $825. So principal times rate is 0.06 times X. Our time is 1, right? Interest. So that's 1 year. Plus principal times rate. So we have 0.05 times 3X plus 1,000. And that's equal to $825. So clearing parentheses, we would go 0.06x plus, now read the 0.05. 0.05 times 3 is 0.15x. Then we have to say 0.05 times 6,000 is 300, equal to 825. So again, we combine like terms. 0.15 plus 6 is 0.21x plus 300, 125. So we can subtract the 300 from both sides. So we get 0.21x is equal to 525. Now if we divide 0.21, we get 25 divided by 0.21 is equal to 2,500. Okay, so that tells us that this artist invested $2,500 into the account that is 6% interest. Now, how much did she invest at the other rate? Well, that's 6,000 more than 3 times the amount we invested at the cent. So we have to do 3 times the 2,500 plus the 6,000, which is what? 7,500 plus 6,000 is 13,500 at the 5%. Oops. Okay. So our answers are 20,500. The next type of problem is going to deal with the denomination of money that we talked about. So just to kind of, how much money do you have if you have a collection that consists of 15 dimes and 4 nickels? Well, to find the value of that collection, you have to know the worth of each of the coins in your collection. Right? We know a dime is worth 10 cents, or as a dollar amount, that would be 0.10. A nickel is worth 5 cents, or it's a dollar amount, 0.05. Two ways to express it. You can express it either in cents or dollars. So in cents, we would say 15 times 10 cents plus 4 times 5 cents would be 150 plus 20, which would be 170 cents, or as a dollar amount, that would be $1.70. Okay? So to know the worth, we have to know how many we have times the value of that coin. Excuse me. How much is X quarters worth? So we're getting now into an unknown situation where we don't know how many we have, but we know they are. So if I wanted to find the worth of X quarters, just like I did above, I had to multiply the value of the quarter times what I have. So the value of the quarter is 25 cents. The decimal would be 0.25 times the X. Or if you wanted to keep it in cents, it would be just 25x, understating that is value. Now what about how much is X $5 bills worth? Well, here again, I have to multiply you of a $5 bill, which is $5, times the number that I have. So since dollar amount, we would just say 5x. Now the word problems that you're going to see that deal with this tell you the total of your collection, and you have to find how many coins was in. Excuse me. So here we have a coin collector has $1.70 in dimes and nickels. She has 2 more dimes than nickels. How many nickels does she have? So we have to look at, first of all, what are our unknowns? Our unknowns are nickels and dimes. If we let nickels be n, the number of dimes is n plus 2, right? Because it says she has 2 more dimes than nickels. Well, we know that the value of nickels plus the value of the dimes will equal our total value. Well, how can I find the value of the nickels? If I have n nickels and they're worth 5 cents each, or as a dollar amount, 0.05, the value of that would be 0.05 times n. The value of the dimes, I know the number that I have times the value of the dimes, which is 0.10. So my value, 0.10, times the number, which is n plus 2, and that's equal to the dollar amount, which is 170. I could convert everything to cents if I wanted to. I would have 5n plus 10 times plus 2 is equal to 170, not 1.7. But we'll leave it in the dollar amount. So now I'm going to simplify on the left to get 0.05n plus now distribute 0.10n. What is 0.1 times 2 is 0.2, and that's equal to 1.70. Combine like terms, 0.05n plus 0.10n is 0.5n plus 0.2 is equal to 1.70. We can subtract 0.2 from both sides, and that was 0.15n is equal to 1.50. Now dividing 1.5. N is equal to 1.5 divided by 0.15, which is 10. So this tells us we have 10 nickels and how many dimes would we have? N plus 2, which would be 12. Right. And how can we check this? 10 nickels is worth 10 times 0.05, which is 50 cents. 12 dimes is worth $1.20. So together they are $1.70. The last problem is similar. A convention manager finds she has 1,242 bills. How many of each kind does she have? Now, I said it's similar, but it is different in one respect. It doesn't tell us specifically how the number of 20s and 50s relate like the last problem. Instead, it just tells us how much we have together. So think about this. If I have a total of 42 bills, I could have 20 and 22, right? I could have 10 and 32. The main thing is that together they have to add up to be 42. So if one of them is x, the other one has to be the difference between that and 42, which would be 42 minus x. So we don't know those other two. I've just shown you as an example. So here, if we let x equal the number of 20s, and then the 50s would have to be 42 minus x. So the same type of thing applies. We need to find out the total value of all the 20s plus the total value of all the 50s, and together they're going to equal this $1,290. So if I have X $20 bills worth $20 each, the total value of that is 20 times X. If I have 42 minus X $50 bills, each worth $50, the total value is the worth of the dollar bill times the number that I have, which is 42 minus X, and together the collection is worth $1,290. So multiplying through, I get 20X plus what's 50 times 42 is 2,100 minus the X is that equal then to 1,290. Be careful here with combining like terms. 20x minus 50x is a negative 30x. It's 2,100 is equal to 1,290. So we have 2,100 from both sides. So we get a negative 30x to 1,290 minus 2,100. And that is a negative 810. So I both sides by negative 30. So x is 810 divided by negative 30, which is 27. So that means we have 27 $20. And how many 50s? Well, the number of 50s is 42 minus 27, which is 15. Okay. So what we've talked about in this section are word problems specifically that deal with interest and the total value of a collection of dollar bills or coins. If you have any questions, please contact me. Thank you.